Hello, seventh grade. We've talked a little bit before about how to solve some really easy equations, which are called one-step equations. We'll get into that in a second. But today we're going to take a much more general look, kind of a wide look at how to solve equations, just any old equation you see. So, quick reminder, when we see equation, we see EQU here, and that should remind us of equals. So anything with an equal sign is going to be an equation. There can be stuff on one side, there can be stuff on the other, but it has to be equal to each other. So that's what makes it an equation. That is an equation. And when we're solving equations, we normally get something that looks, that has a variable in it. So our favorite variable for some unknown reason is x. And so I have x, and let's say x plus 3 equals 5. And if I'm looking at this means something plus 3 equals 5, and we can just say that, well, 2 plus 3 equals 5, of course. So then x equals 2. But that's not really the most mathematical way to do it, and sometimes we'll get things that aren't quite as easy to just spot as that. So what we've done in the past is I've told you guys to look at what's being done to x. In this case, it's addition. The opposite of addition is subtraction. So opposite operation. So the opposite of addition is subtraction. So I'm going to subtract 3, and I'm going to do that from both sides. So what I end up getting is x is equal to 5 minus 3. That's the same thing, which gives me x equals 2. So these two statements tell me the exact same thing. They're the same. So when we're working with operations, it's kind of important to note that we have two rules. And the first rule is that anything we do has to be done to a whole side. So any operation is done to a whole side of our equation. Which means we can't just pick parts and say, I want to multiply this part but not that part. We have to do it to the whole thing. And my second rule is that if we do it to one side of the equation, we have to do it to the other. So anything done to one side is done to the other. And other than that, we can do whatever we want. So that gives us a whole bunch of freedom to work with when we're working on these problems. So when I'm looking at an equation, I'll do a slightly different one. Let's try 3x equals, let's say 15. I could just look at this and say 3 times something's 15. Well, no, 3 times 5 is 15, so x must equal 5. Or what I can do is this 3 is multiplying the x, the opposite operation of multiplication. The opposite of multiplication is division. So I'm going to take this side, I'm going to divide it by 3. And I have to do that to the whole side. And then if I do it to this side, I also have to do it to the other. So I'm going to divide this side by 3. And what that gets me is x equals 5, because 15 divided by 3 is 5. 3 times x divided by 3 becomes just x. This is a little bit more complicated than stuff we've done in the past, but we should be able to just jump right in, I am hoping. So I want to look at a bit of a more complicated problem now. And what that more complicated problem is going to look like is going to be 3x plus 2 equals 20. 3x plus 2 equals 20. So looking at this, I have to follow my two rules. So if I do something, it has to be done to the whole side. And if I do it to one side, I have to do it to the other. So looking at this, I need to make a strategy. And my goal, anytime I see this, is to get the variable alone. So my goal is to get the variable alone. So looking at this, 3x plus 2, my x right here is my variable, and I want to get that alone. Because if I get that alone, I'll have x equals something, and that something's my answer, and I'm done after that. So I want to get x alone. And I'm allowed to do whatever I want to either side of the equation, as long as I do it to the whole side. So I'm going to look at this, and I want to do it two different ways, and then talk about strategy a little bit. So the first way is the best way, and I'm not going to tell you why quite yet, but I'm going to start by looking at what is by the x. So if I want to get x alone here, I have 3x plus 2 equals 20, and my goal is to get this x alone. So what's next to the x? Well, there's a 3 and there's a 2. And the best way to do this, I'll tell you why later, is to get rid of the 2 first. So if I get rid of the 2 first to get x alone, is I would subtract 2, and I would do that from both sides. And I have 3x plus 2, and then I would subtract 2. And that has to be equal to 20 minus 2. So I subtracted 2 from both sides, and I did it to the whole side, so we're good to go. So looking at this, 3x plus 2 minus 2, anytime I have a plus 2 minus 2, those will cancel out, and I end up with 0, 3x plus 0, which is just going to be 3x. And on this side, that's going to be equal to 20 minus 2. 20 minus 2 is 18. So I'm a little bit closer to getting x alone. I used to have 2 things next to x, the 3 and the 2. Now I just have the 3. So now what I'm going to do is to get rid of the 3, I have to find the opposite operation of what's going on. The 3 is currently multiplying the x. So the 3 is currently multiplying the x, and the opposite of that is division. So I'm going to take my side right here, 3x, and I'm going to divide all of that by 3. That has to be equal to 18, and take all of that divided by 3 as well. So 3 times x divided by 3, we have a multiplied by 3 and a divided by 3. Those cancel out, and I end up with just an x on this side, and that's going to be equal to 18 divided by 3, which is 6. There we go. 6. So x equals 6. And I told you guys this was the easy way to do it, which of course means there's a hard way, and I'll show you guys that now. And both ways work just fine. So looking down here, now I have 3x plus 2 equals 20. And again, my goal is still going to be to get x alone. But this time, I just kind of arbitrarily chose the 2, and I told you guys that was the best way. I want to show you guys what happens if we get rid of the 3 first. So let's get rid of the 3 first. We have 3x plus 2. And to get rid of the 3, we're going to have to divide by 3, because again, that is multiplication here. The opposite of that's division. But if we do something, we have to do it to the whole side, which means that we're going to have to divide this whole side by 3. And that's going to be equal to 20. And I did it to the left side of my equation, so I'm now going to do it to the right-hand side of my equation. So anything I do over here, I also have to do over here, and it has to be done to the whole side. So if I do this to the whole side, I end up getting something really kind of gross and messy. That's all right, which would be 3x divided by 3 plus 2 divided by 3. So I had to do it to the whole side, so it happened to both of these things, right here and right there. And then on this side over here, I would get 20 divided by 3 equals 20/3. And thankfully these cancel, and end up with x plus 2/3 equals 20/3, which is kind of gross. We have a bunch of fractions. That's no fun. But we're going to continue. And to get x alone, I need to get rid of this right here. I see my addition, so what I'm going to do, I'm going to find the opposite of addition. Again, what I do here is I look at the operation that's going on, and I find the opposite of it. So right now there's addition. The opposite of addition is subtraction. So I'm going to take my x plus 2/3, and I'm going to subtract 2/3. And I can do this to the whole side by putting parentheses here, but the parentheses don't really do anything, so I'm just going to leave them off. And that's going to be equal to 20/3. And again, I have to subtract 2/3. So looking at this, now I have x plus 2/3 minus 2/3, which is going to give me x equals 20/3 minus 2/3. They already have a common denominator, so 20 minus 2 is 18 divided by 3. And simplifying that, I get x equals 6. And this method right here is obviously a lot harder and more painful than this one right there. So the question is, what was the difference? And the difference is in the second one. I did the multiplication before I did the addition. In the first one, I did the addition before the multiplication. So you don't have to do this, but a pro tip is that I would always subtract or add before multiplying and dividing. So if you can, dividing has that. Okay, if you can choose which one to do first, always take care of the subtraction and addition before you do the multiplication and division, because otherwise you're going to end up with a bunch of fractions, and that's not going to be fun for anybody. I want to give you guys a problem real quick, which is going to be 3x plus, we did 3x last time. Let's make it 5x plus 7 equals 42. 5x plus 7 equals 42. If you'd like to pause the video right now to see if you can do it, that'd be a great idea. And then unpause it, and I'll show you guys how I'm going to do this. All right, so looking at this problem, my first thought is that I need to take care of the subtraction and addition before I do the multiplication, which can be this bit right there. So I have my 5x plus 7. And the opposite of addition is subtraction, so I'm going to subtract 7 from this side. And that has to be equal to 42. And I have to do it to both sides, so minus 7 here. What I end up with is 5x equals 35. After that, I'm going to do the opposite of the multiplication here, which is division. So I have 5x, and I'm going to divide that by 5. That's going to be equal to 35 divided by 5. And 5x divided by 5 is just going to be x equals 35 divided by 5, which is 7. And just like that, we are good to go. So there's a whole bunch of different ways equations can look with this. Some of them will be uglier than others. I want to look at just one more type real quick. Sometimes you'll get some really ugly looking equations that have something like 3x plus 4 minus x equals 28. And if we're looking at this, I'm going to give you guys one more pro tip, and that pro tip is going to be that we should combine like terms whenever we can. Let me do that in purple again. I liked the purple for the pro tip. That was fun. Pro tip. Combine like terms whenever we can. So looking up at this, I have 3x plus 4 minus x equals 28. And anytime we see a variable, I like to think about that as any random word that pops into my head, and right now that is giraffes. So I have 3 giraffes plus 4 minus a giraffe equals 28. So looking at this, if I have 3 giraffes and I take away a giraffe, 3 giraffes minus 1 giraffe is going to be 2 giraffes plus 4, so the 4 still has to stick around, and that's going to be equal to 28. And after that, we can solve it as usual. Like I said before, I normally try to take care of my addition and subtraction first. So I'd get rid of this 4 here, and I would have 2x plus 4 minus 4 is equal to 28 minus 4. Again, doing that to both sides, which gives me that 2x equals 24. And now by dividing both sides by 2, these cancel, and I end up with x equals 12. That's all I got. I know today was a bit of a longer video. If you need to watch it through a few times, I would understand. This is one of the harder concepts of this whole year, and we're going to be using it as we go forward in 2 years in the future. So please make sure we get that very solid down pack ready to go. Other than that, please make sure that we do the practice set along with these notes and bring those into class with it, and we should be good to go. I will see y'all in class.